Now, let us just recall from the table that we actually formed a few classes ago. We got the expression for voltage across the valve. So, let us just see what is that. The last column, voltage across one of the valves, valve 1. Now, I said why we consider only one of the valves. The reason is all the valve voltages will be identical except for a phase shift. So, even if you go back to the previous definition, say commutation margin angle, we say that the angle for which the voltage across the thyristor valves is negative. That means, for any thyristor valves it is negative for the same duration, that is what I mean. Okay. So, if you take the converter with 6 thyristor valves, for all the 6 thyristor valves, the angle for which the voltage is negative after it stops conducting is same. Okay. So, voltage across thyristor valve. So, we will just consider we had 6 expressions corresponding to the 6 intervals. I will just consider the first 2 intervals. The first 2 intervals are omega ot greater than alpha and less than alpha plus 60 degrees, alpha plus 60 degree less than omega ot less than alpha plus 120 degrees. So, we got the expression. So, the first 2 rows I am taking. So, for alpha to alpha plus 60 voltage across valve 1, we got the expression as EA minus EB. And for alpha plus 60 degrees to alpha plus 120 degrees, it is EA minus, we got the expression, right? EA minus okay. So, for the first 2 intervals, this is the, I mean, we actually got the same expression. So, okay, I could have written differently. Okay, what I can do is, okay, I will do this, sorry. Suppose I take the next 2 intervals, alpha plus 240. So, from alpha plus 120 to alpha plus 240, it is EA minus EC. Yeah, I meant to just take these 2 expressions, not 2 intervals, it is actually 4 intervals. Of course, there are 2 more intervals where it is negative, sorry, where it is 0, Okay. Now, let us try to plot this voltage, that means the voltage across valve 1. See, what is EA minus EB? Let us get the expression for EA minus EB. What is EA minus EB? We have the expression for EA and expression for EB. EA minus EB. EA is having a phase angle of 150, EB is having a phase angle of 30. So, EA minus EB is a line voltage with RMS value V. So, it is root 2 V, yeah, minus root 2 V sin omega out. So, it is minus root 2 V sin omega ot. Then there is another expression for voltage across valve 1, EA minus EC. So, if you look at the expression for EC, the phase angle is minus 90. So, EA minus EC is root 2 V sin omega ot. EA is having phase angle of 150, EC is having a phase angle of minus 90. So, minus EC will have a phase angle of plus 90. So, one is 150, another is 90. So, the resultant is EA minus EC 120. So, it is root 2 V sin omega ot plus 120 degrees. Now, let me try to plot voltage across valve 1. So, what I am trying to do here is plotting voltage across valve 1. So, before that I will just try to plot EA minus EB and EA minus EC also. So, that over that I can plot voltage across valve. Suppose this is 0, this is say 60 degrees, 120, 180 degrees, 240 degrees. So, if I plot EA minus EB, EA minus EB is minus root 2 V sin omega OT. So, there is a negative peak at 90 degrees. What I am plotting is EA minus EB first, minus root 2 V sin omega OT. Is that okay? See, the peak value is at, okay, not be a very neat sketch. Then suppose I plot EA minus EC. EA minus EC is root 2 V sin omega OT plus 120. So, where will the 0 crossing of this be? So, there will be a 0 crossing from positive to negative at EA minus EC. EA minus EC will have a 0 crossing from positive to negative at, sorry, 300. Anyhow, 300 I have not shown here. What I have shown is 0, 60, 120, 180, 240, 60, 60. This is just a rough sketch. Okay. Now, suppose I have alpha say greater than 60 degrees. Suppose alpha is greater than 60. Let us make this assumption. We will consider what happens if alpha is less than 60 later. Suppose alpha is greater than 60 degrees, then from alpha to alpha plus 120, it is the voltage across valve 1 is EA minus EB. So, suppose I plot EA minus EB. Oh, sorry, made a mistake. Suppose I plot voltage across valve 1 using this red line, voltage across valve 1. So, from alpha to alpha plus 120, it is EA minus EB. So, I will show somewhere alpha is somewhere here. This is alpha. Okay. So, up to alpha, that means just before alpha, what is the value of voltage across valve 1? Why? See, alpha is the instant at which valve is turned on? Which valve is turned on at alpha? 3 is turned on. See, alpha is the instant at which 3 is turned on. So, before 3 being turned on, which valve is conducting? one is conducting. So, we are trying to plot voltage across valve 1. When a valve is conducting, voltage across the valve is 0. Okay. So, voltage across valve 1 before alpha is 0. So, I will just show for a small duration for which it is 0. Okay. I am not trying to show it from 0 to alpha, I am just showing for a small duration before alpha. So, at alpha it jumps to voltage across valve 1 jumps to EA minus EB. So, EA minus EB is this level. Okay. So, it remains at EA minus EB up to what? Up to alpha plus 120. So, alpha plus 120 comes after 180 degrees, because I have assumed alpha greater than 60. So, alpha plus 120 is after 180 degrees. So, up to alpha plus 120, the voltage across valve 1 is EA minus EB. So, this red line coincides with this curve EA minus EB. Then what happens at alpha plus 120? It becomes EA minus EC. So, it jumps to EA minus EC. Okay. Right. So, this red line is the voltage across valve 1. Now, just go back to the definition of the commutation margin angle psi. What is the commutation margin angle? That by definition it is the angle for which the voltage across the thyristor valves is negative after it stops conducting. So, if I take voltage across valve 1, valve 1 stops conducting at alpha. So, what is the duration for which the voltage across valve 1 is negative? So, that means what is the commutation margin angle? 180 minus alpha. So, commutation margin angle psi is 180 degree for this case minus alpha, which is nothing but beta. By definition, beta is 180 minus alpha. Now, this is as far as the range of alpha from 60 to some value which we have to determine. Now, this diagram actually, this waveform actually tells us what is the upper limit on alpha. So, looking at the previous definitions, can we say if alpha is greater than 60, can it go up to any value, or is there a limit?
There is a limit.
What is the limit?
Such that 180 minus alpha is always greater or equal to epsilon.
Yeah. So, there is a quantity called psi naught. There is a minimum duration for which voltage should be negative. So, alpha cannot go up to 180, it can go only up to 180 minus psi naught. Okay. So, alpha is greater than 60 and alpha is actually less than 180 minus psi naught. Okay, you can of course take the value of 180 minus psi naught also, less than or equal to 180 minus psi naught. Now, let us consider the other possible range of alpha. So, that was for alpha from 60 to 180 minus psi naught. Okay. So, what happens to alpha less than 60? Yeah, please note psi naught is a small value, it is of the order of 10 to 15 degrees. Okay. So, it is it is a small angle compared to a 60 degree, it is a small angle. Now, let us see what happens if alpha is less than 60 degrees, and of course greater than what is the minimum possible value of alpha? 0. So, between 0 and 60, what will be the waveform? So, what I want is the voltage across valve 1, Of course, I can also plot this EA minus EB and EA minus EC, and from that I can plot voltage across valve. And once I plot these waveforms, I can get the expression for the commutation margin angle. So, can you just attempt this?